Now we examine the circuit variables, the relation between the circuit variables and the circuits, that one. And then we said there are two fundamental variables, which are current and voltage. And in here we examine these current and voltages and also learn how to measure current and voltage by a multimeter, or voltmeter and ammeter. The next step is we are going to talk about the other variables, which are power and energy, and their relation between power and energy and these fundamental variables. Before that, let's examine. We need we do require to make a convention about the references that we have just seen. So we are using two references. One of them is voltage reference, the other one is the current reference. Can we reduce these two references just by one? If we make a convention, so we could do that. So what is this convention? It says it's a convention between current and voltage references. Current reference arrow should be from plus to minus polarity of the voltage references. So that means if you know the voltage reference of an element, so you can choose your current reference according to that convention on this voltage reference. How are you going to do it? You're going to put an arrow starting from the plus, ending at minus. So we could do the other way around. If we know the current reference of an element, then we could, according to this convention, we can find out the voltage reference. Beginning of the arrow we are going to put plus, and end of the arrow we are going to put minus. So this convention reduces two reference choices to one. That's one advantage. The other advantage will be effective on the definition relation of elements. We will see the elements next chapter. In this chapter, this relation, in the definition of this relation, mathematical relation, we need this convention, otherwise there's going to be a problem. So I will explain this in details in chapter 2. And we are going to use the new benefit of this convention in the next frame. This convention will be effective for power delivery and power absorption. What are they? I will be explaining in this frame now. So if you look at this frame, power and energy, so we said these are the other variables. These variables can be explained or explained on the base of the fundamental variables, which are current and voltage. Power, we know this power is the derivative of energy in the physics. That's true, so we know it from physics. So we can divide this derivative into multiplication of those two terms. In here, dw over dq, and multiplied dq over dt. dq's disappear, so dw over dt, which is the derivative. So the first term in this equation, if you look at the previous one, the voltage is dw over dq. That's the first element of this multiplication. The other term, the next term in this equation, is the current. That means dq over dt. So this P becomes multiplication of Vt and It. So that means power is the multiplication of the fundamental terms, fundamental variables, voltage and current. So if you consider an element power, so that means we are going to measure the voltage and current of this element and multiply these voltage and current, then we can say that the multiplication result is this element voltage. So units for the power is watts, Energy is joule, time, seconds, voltage, volts, current, amperes. So this is the power we just seen, that multiplication of these fundamental elements. The energy is the integral of the power. So you could say that the integral, inside the integral, V2 multiplied IT, integral of this multiplication gives you the energy. So energy of this element. So question now, when we are talking in the elements, some of them they consume or absorb power. Some others deliver power. For example, at home, all the electrical equipments, refrigerator, TV, washing machine, whatever it is, they all absorb power. In order to run these machines, we need electrical source, and we consume or absorb electrical power to run these equipments. So there is another element in our house, which are mains, plugs. These plugs gives our energy sources. So they deliver electrical energy or electrical power. So how we are going to differentiate whether an element deliver a power or absorb a power? So to answer to that question, we will make an agreement saying that if the voltage at current references of an element is chosen according to passive sign convention, and the resulting power calculation sign is negative, then we say that element delivers or supplies power. If the resulting voltage sign is positive, then we say this element absorb or extract power. So without using the passive sign convention on these references, we cannot separate whether an element delivers the power or absorbs the power. So this distinction, we need this passive sign convention. So what we have seen in this chapter, we could see it on here. We talked about circuit variables and their relation with the circuits and the basic concepts, analysis and synthesis, practice and theory. And then we said there are two fundamental circuit variables, which are current and voltage, and we learned how to measure these voltage and current, and then we introduce the energy and power of the elements in a circuit.